Good evening, my dear NEET 2025 warriors. Welcome to the 1000 questions plus in 7 days challenge, which we have started this particular week, and you're already on to day 3. So, today in day 3, yes, this is the last session. Your physics, chemistry is over, biology is over, and now we are on to magnetism, EMI, AC. All the chapters covered this particular unit of magnetism which is there. We are going to do that. Previously, we have completed electricity, electrostatics, gravitation, and also kinematics and mechanics. So stay tuned on the channel, because if you are just even watching these classes and probably just scribbling through your rough sheet, you are solving 1000+ questions, which otherwise you would have wasted, or probably you would not have got that information or that knowledge. So make sure you are sticking around till the end and see every single question being solved with your captain, Shreyas, who is going to take your physics sessions with the entire team of Vedantu NEET Warriors. So, thank you for tuning in. This is your Captain Shreyas, and I have done my BTech from NIT Nagpur, did my research from IIT Bombay. I have produced the top ranks in the country, be it JEE, be it NEET exam. And that's why I'm here to make sure this year top ranks are you. You are the top ranks. And if you sincerely follow the sessions, you too will be sitting inside the AIMS campus and messaging me next year. I really hope this dream of yours come true. And if you want this dream to come true, quickly smash that like button and also subscribe to the channel. Welcome everyone. Atluru, nice to see you after a long time. Minecraft, Krishna, Warrior Pandu, welcome. Good evening, Aishwarya. Hi, Craft. Welcome, Devanshi. Sir, whether upcoming DNA batch timing is at the evening, sir, which is, no, it will be in the afternoon evening time, because many dropper students are also involved, and usually the evening time is kept for our pro batches plus our YouTube. So that's the reason for that. Yeah. Okay. Good evening, Suchi Mama. Welcome, 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 Mamta, Jinendra, Susmita. Good evening, good evening, good evening, everyone. Siva, yes, Risti. Finally, everybody is waking up. Great. Now I want that same enthu, in fact, even more enthu while answering the questions. Okay. First question on your screen now. A wire is bent in the form of a semicircle. Radius r carries current I. The magnetic field at the center of the semicircle. These kind of questions very standard. Now remember one thing, whenever you have a wire, which carries current, then on the wire's axis, the magnetic field contribution of that wire is always zero. Only the magnetic field will exist around that wire. Around that wire, there is magnetic field, but not on the line of the wire, which means this part and this part, which make sure that this point is on the line of that wire, their contribution will not be there. So there will be no contribution in the field. There will be no contribution of the magnetic field due to the long wire, because that point is on the line or the axis of that wire. So the only contribution is going to come from that semicircle at that point. So magnetic field due to that particular semicircle will be exactly half of the magnetic field due to the complete circular loop. Due to the entire circular loop, it's exactly half of it. Magnetic field due to circular loop is mu naught I divided by 2 times of that particular radius. So hence it will be mu naught current divided by 4 times of R. Mu naught I divided by 4 times of R, which is C option. Correcto, correcto, correcto. Amazing, amazing. Very good. Many of you gave option 3. Great. Yes. Shall we move ahead to the next question coming up on your screen? Okay, here it comes. A long, straight, thin conductor has a current I ampere. The magnetic field away from the conductor at a distance r from the axis varies as. Okay, so we have a long straight wire, thin conductor like this. So this is carrying current I. So if I am some distance away from it, this is that particular R, the magnetic field is given by mu naught I divided by 2 pi R. Clearly the magnetic field is inversely proportional to R. So it can't be this or this. It has to be a curved line. Yep. D. Very good. D for doctor. Very good, Suchi Mama. BV KKS. So yes, Susmita. Yes, Jinendra. Wow, we have two Susmitas over here. Oh, amazing. Devanshi, correct, correct. Yes, Mamta. Yes, Krishna. Great. Moving to the next question. If you remember the formulas, you will get it. B1, B2, B3 are the magnetic fields due to I1, I2, I3 in the Ampere's law. Then B dot dl is equal to mu naught I. B is what? What is that magnetic field in that Ampere's law? Where mu naught I is that enclosed current. So what do you think is that magnetic field inside that? Is it due to the first current, second current, or first current minus second current, or first current, second current, third current, all three of them, or some signs will be also involved? What do you think? This is very conceptual question. There is nothing to solve over here. Okay, I'll remind you that this current is always the enclosed current, and enclosed current in this particular case will be I1 and I2, but they are opposite. So it will be I1 minus I2 if this current I was asked. But if you ask me, what is this? This one is always the net magnetic field. The same logic is also there in Gauss's law. It is always the net magnetic field, both due to inside as well as outside. So the magnetic field due to 1 will be there, the magnetic field due to 2 will be there, and the magnetic field due to 3 will also be there. Their vector sum should be taken. Yes, it is always their vector net, or basically vector sum. Yep. So there is no question of minus or plus. It's always added. It's always added. Yep. So it is not option A. Some of you thought it was option A. No, it is B for biology. B for Baswasaurus sir. Very good, Atluru. I hope Susmita you got it. Yes, Sushi Mama, correct. Exactly like Gauss law. Same question can come with Gauss law. E dot ds is charge in by epsilon. Charge in is inside charge. E will be the total field, both due to inside as well as outside. So that is the funny part about this equation. LHS has both in and out, whereas the right hand side has only the inner components or the enclosed parts. So that is what it is. Okay. Next one. Find out the magnetic field at the point O for the following current distribution. It's a modification of the first problem that we just solved. Yes, the modification of the first question that we just solved. So as you can see, my dear students, this particular part and this particular part will not participate in producing any magnetic field here because it is on the axis. On the axis, there is no magnetic field, only around it there is magnetic field. Now, if you ask me, what about this guy? Yes, definitely it will produce magnetic field over here. The current is going like this. Curl your fingers of your right hand, the thumb will come towards you. So the magnetic field is going to be towards you. That magnetic field will be half of that entire loop. So the loop will produce mu naught I by basically 2R. That is the magnetic field due to this part. Similarly, what will happen is this particular part, which is carrying current I, if you curl your fingers in the clockwise direction, the thumb will go inside. So the magnetic field will be inside like this. It will have, again, half of the contribution of the entire loop if it existed. So it will be mu naught current divided by 2 into that particular radius is 2R. As you can see, this is smaller, this is bigger. So therefore, I can easily say that our net magnetic field will be this minus this. This is bigger, this is smaller. So you can see this is 1/4, this is 1/8, this is 1/4, this is mu naught I divided by 4R, I believe, and this is nothing but mu naught I divided by 8 times of R. So when you obviously subtract them, you will be left with 1/4 minus 1/8 is 1/8. So this will be mu naught current divided by 8R. If you ask me the direction, this is more, this is less. That means outside is more, inside is less. So the net magnetic field will be coming towards you. So mu naught I divided by 8R. If direction was asked, then it will be out of the plane of the board. Yes, out of the plane of that board. Yes, B for biology, B for Baswa. Sir, correct. Great, great, great. Very good. Awesome, awesome. Very good. Same, but different. Correct. Very true, Krishna. Important chapters for physics. Who is asking that? Aishwarya. Aishwarya, did you attend my yesterday's class? I gave one very important statement yesterday. NTA is unpredictable. Priority order failed for JEE. Number 3, NTA, CBSE, NCERT involved. And physics paper, crazy, mind-blowing, bazooka it was. So, if you go by the same strategy which you might have seen, heard, or have applied in 2024 or in 2023, it will not work. Mark my words. So please do not listen to any such stupid list. There is nothing like a list of chapters or topics which you should do. Although I can give you some important chapters, I will make a video of important things which you should know because they will be useful everywhere. But please try to cover as much of the syllabus as possible. Low weightage topics like fluids, electromagnetic waves, or even sometimes semiconductors were given higher priority this time. And the high weightage topics like EMI or sometimes even rotation were asked less. Surprisingly, ray optics was asked too much. So there is nothing which we can predict. So please, my humble request, do not listen to such YouTubers because they are YouTubers, they are not teachers. I am not a YouTuber. Let me tell you, I'm a teacher. Understand? Okay. So I will think what is good for you. I will not think about views. I will not think about all those things. I want your marks. Views will come and go. Your marks, it will stay with you for your life. Understand that. I'm worried about that. Okay. A long wire carrying a steady current is bent into a circular loop. One turn. The field at the center is, I think, B. B is missing, I think. Yeah, I think that word B is missing. Okay. If it is then wound into a circular coil, I think N is missing, of N turns, then the field at the center will be how much? Yeah, I hope this is absolutely clear. Okay. Okay. So this is a very interesting question. First of all, if you just have one turn, the magnetic field at the center is given by mu naught I by 2 times of R. But now what we have done is we have made many turns out of it, So the new magnetic field will be mu naught I to new radius, but there will be n number of turns. Now you will ask what will happen to the radius. Well, the logic is very simple. I'll tell you what. See, the total length of that particular wire should be constant in such cases. So it should be constant in such cases. So whatever was that original length, which will be the circumference of the circle, which is 2 pi r, should be equal to the final length in this case, which is 2 pi your new r, 2 pi your new r, but multiplied by n. So obviously R1 is R by n. So here what I should put is technically R by n. Now you will notice this will become mu naught I by 2R. N multiplied by n will become n square. But as you can see, this entire term mu naught I by 2R is nothing but magnetic field which was there previously. So hence that new magnetic field is the old field multiplied by n square times. Lot of people give answer as A, They think if you wind it n times, it will increase n times. Correct. But there is one more factor which comes because of the radius changing. So if you forget that the radius is changing, then you will get negative marks, -1 marks. Yep. Many students had given the correct answer and I'm very proud of it. Very proud of it. Very good. Yeah. Yes, I might have solved a similar question before also, but remember, as many times as you solve similar questions, it is better for you, because if you see familiar questions in the exam, you will 100% be super duper confident. And that is what NEET toppers do. They don't think, oh, I have solved it before or after. They get very happy if I've solved it 100 times, 200 times. Great. But that means for sure I will be able to do it in the exam. That confidence will come to you. When there is a magnetic field applied on a stationary electron, then what do you think will happen? Well, I think this is based on Lorentz force. And the Lorentz force formula is the charge into the velocity cross-producted with the magnetic field. It is stationary, so velocity is zero. So obviously force will be zero. If force is zero, by Newton's first law, Newton's laws of motion, first law, it will, a body at rest stays at rest unless acted upon by an external force. So that means it should remain in the same situation. It should just maintain its situation. Answer is A. Very good. Awesome. Great. Very good. Yep. Remember, yes, just like that combining of the drops. Yes, yes, that is a very popular question. Oh, by the way, in JEE first attempt, NTS popular question was joining those drops for either capacitance or for surface tension, work done, or coalescing and finding the new radius, or for finding the potential. Popular question that was. So yeah, volume conservation based, very popular. We don't know whether NEET will ask or not, but we should practice. We should be open for everything. Resistance of a moving coil galvanometer is 4 ohm. When 0.2 volt is applied, then it shows full scale deflection. In order to measure 20 ampere of current, then what should be that shunt, as in that parallel resistance that you should apply? Yeah. Awesome. I'm a student of Crash. I'll take the test after the stipulated time. Will you consider it for Ekalavya? Harini, I would suggest don't play with fire. Don't do that. I think you should give it at the same time because the ranking will not come. So better give it on the same day. Okay? Because generally we consider students who give it on the same day only, not on the next day. You will get your marks, but not the rank. Okay, so what do we do over here? See guys, first of all, we know that it shows full scale deflection when you apply 0.2 volts and the resistance is this much. That means I can immediately find the maximum current which can go through the galvanometer, and that is nothing but the voltage divided by the resistance of that galvanometer. The maximum voltage is 0.2. The resistance of the galvanometer is 4. So 2 by 4 is half. So this is nothing but half, but you have a 0.1 over there. So that 0.5 is there and the decimal is also there. So this will be 0.05 ampere. 0.05 ampere. Yes, that is the maximum current which can go in that galvanometer. But that is not the question. The question is, what is the shunt resistance? So if you visualize the circuit, it will be easy. You have the galvanometer over here, which is having a resistance of 4 ohm, and we know the maximum current which can go through it is basically 0.05 ampere, and when that happens, the voltage across it is basically 0.2 volt. Okay, but we are going to bypass it. We are definitely going to bypass it, and we are going to allow more current in it, which is of 20 amperes, and most of the current will go through the parallel part, which is the shunt resistance. I will call it RS. And how much current will go over here? 20 minus 0.05, which is basically 19.95 amperes. 19.95 amperes. Is that correct, guys? Which is nothing but 19.95 amperes by Kirchhoff's current law, which is as good as saying it is 20 amperes. That decimal places in the second place. So guys, I mean, it's fine. We can almost take it as 20 amperes. So from this, immediately you understand whatever voltage is here, because they are in parallel, the same voltage should be applied over here, which should be 0.2 volts because they are in parallel. And voltage is current into resistance. Voltage across the shunt is the current in the shunt into resistance of the shunt. So this will be 0.2. Current in the shunt is 20 and resistance of that particular shunt is what we have to basically find. Yes, is that right? Is that right? So what is that shunt resistance as it is? So it will be nothing but 0.2 divided by 20. So guys, this will be 1 divided by 100. Now you will notice that 1 divided by 100 is not there. Yes, 1 divided by 100 is not there in the options. What does it tell you? It tells us that this answer is not calculated as approximate, rather it is calculated as exact value. It is calculated as exact value. But whatever value we have got, although I know it is approximate value, why is it approximate? The reason is this this reason is this 20 ampere. I've approximated it as 20 ampere. So out of these four options, which is the closest to 1 by 100? Which is the closest to 1 by 100? Come on, guys. 4 by 500? No. 4 by 300? 299 is like 300. 4 by 300? No. 4 by 200? No. 4 by 400? Yeah, 4 cancels. 1 by 100 is 0.01, which is exactly like this. Yes, this is exactly like this. This is 1 by 100, which is like 4 by 400, you can say. 4 by 400. So 4 by 400, nearest answer is B. So you will give the answer as B. But if you calculate it with 19.95, you will exactly get this. But you have to play it smart in the NEET exam. Don't waste your time. Oh, I have to calculate it exactly, sir. What are you doing, sir? I will put 19.95. Sir, 19.95, sir. I have to calculate it. So difficult calculation. Don't do that. Waste of time. Okay. Is that clear? Awesome. Can I do obsession J for physics? Yes, we'll be doing some amazing series for J. Don't worry. Stay tuned. Right now, maths exams are going on. So as soon as that is done, you know, few IT exams, that exam is there. So then we'll be doing it. Okay. What happened to Diksha ma'am? Oh my God. What happened? Jyoti, where is she? Ooh, Diksha ma'am, right? You should ask Diksha ma'am when she comes back. Or is she coming back? I don't know. Okay. Very questionable thing. Right now, Nitika ma'am is there, but whether Diksha ma'am will come back or not, we have to see. Okay. But for that, Diksha ma'am had messaged me yesterday. She said that, sir, I will only come after the subscribers will go to 201k. 201k. At least 201. I don't know why she said that, but maybe some reason might be there. You should ask her. So let's see how fast you make it 201. Else Diksha is like, no, sir, I will not come. Okay, great. Let's move to the next question. Torque on a current carrying coil is maximum when the coil is suspended in a radial magnetic field such that the plane of the coil is parallel to the external field. Okay, the torque depends on the magnitude of the applied magnetic field and the orientation of the magnetic field with the plane of the coil. You know, this concept is based out of moving coil galvanometer. Yeah, moving coil galvanometer. Yes, come on. If you take a moving coil galvanometer, the field which is applied on the coil which rotates is a radial field. And what happens because of that, no matter how that coil is oriented, you will always notice that the magnetic moment will have some magnetic field which will always be perpendicular. If you rotate it like that, another magnetic field, radial field. So there will be always radial field, which makes sure that always a magnetic field is in the plane of the coil and perpendicular. Oh, okay. So such that the plane of the coil is parallel to the external field. Yes, the plane of the coil, as you can notice, the plane of that coil So this is that plane of that coil. Definitely is parallel to the external field. Definitely the first assertion is correct. The reason is the torque depends on the magnitude of the applied field, the orientation of the magnetic field, and with the plane of the coil. Correct. So the torque, remember, is nothing but M into basically your B. Yes, M cross B. So it depends on that. And no matter how you orient it, always the field is perpendicular. So that is why the torque on the current carrying is maximum when it is perpendicular to the field, the magnetic moment. So I think the reason is correct, and also it is explaining it properly. If magnetic field was not in the plane, then it was something else, then obviously sine 90 is maximum, sine 60, sine 30, sine 40 will be lesser than sine 90. It won't be maximum. It is maximum only when it is sine 90, basically perpendicular, because sine 90 is 1, only then it is maximum. So I think it is all correct. They are explaining it properly also. No issues. Okay. All right. All right. All right. Great. Let's move to the next question. Two charged particles having same linear momentum describe circular path of radius and respectively in uniform. Transverse means perpendicular. Remember, if you take perpendicular field, the charged particles go in circular orbits, correct? Okay. If the ratio of the respective charges is, then the ratio of dash and will be, ayo, I think lot of things are missing. Two charged particles having same momentum describe circular paths of radius and respectively. I think many things are missing, guys. Some information is missing in this. So anyways, we will try to solve this. Then the ratio of what is also asked, I don't know. Okay, I'll tell you what is the formula which will be used. R will be equal to mv by qb. Okay, over here I think magnetic field is same, the path of the radius is probably different, and if the ratio of their masses might be given, charges might be given, then the ratio of the radius might be asked, I don't know, something like that. So if you see R1 by R2, it will be nothing but M1 by M2, and it will be nothing but Q2 by Q1, assuming their speeds and magnetic fields are same. So this is what you will generally use. If their momentum is same, then the numerator will be same. So it will be inversely proportional to the charge. That's all. So that's how this works. So in this particular question, nothing is given. I mean, misprint has happened. So you cannot obviously get it. Yeah, I'll be sharing the PDF, definitely. No point discussing this question, but you got the formula, right? Radius is mv by qb. That is the formula which you will be using. Okay, very interesting question. Magnetic field at point P, magnetic field at point P due to the arrangement shown in the figure is dash mu naught I by 2. What is that x? What is that unknown factor? Beautiful question. It's based on the concept of finite wires. Now, see, this current will produce a field here. This current will also produce the same field here. By symmetry, their fields, I can just add them, double them, and I will get the total field. So you just have to find the magnetic field contribution due to any one wire, and the other wire will be the same. You just add them up. That's all. So I'll just find due to, let's say, the left side or maybe the right side. Now, if you take, for example, this one, this is the perpendicular distance. This is that wire. It is coming from infinity and it is going from here and it is reaching over here. So it is infinite on one side and it is not infinite on the other side. This type of questions have to be solved using this formula. Magnetic field due to any one wire is mu naught by 4 pi. You have current divided by the distance. I think the distance is A over here, into sine alpha plus sine beta. Remember this formula, sine alpha plus sine beta? Oh, now you will be like, sir, what is this alpha and beta? I'll tell you what it is. If you take the end of the wire and join a line from that point where you are trying to find the field, in fact, it is at infinity. So that is basically alpha. And the end to that point where you are trying to find the field on the other side, that is beta. Because this is infinity, what will alpha be equal to? Won't it be 90 degree? And what will beta be equal to? Come on, put it up in the chat box. This is 90, this is 45. What will this be? Obviously, this will be 45 degrees. 45, 45, 90 triangle. Is that understood? This is that finite wire formula. Alpha, beta are the angles made with the ends of the wire. Oh, sir, now I got it. So alpha is 90, beta is 45. So what is sine of alpha? What is sine of alpha? Sine alpha will be 1. Sine 90 is 1. What is sine beta, sir? Sine 45, which is 1 by root 2. Okay. So therefore, magnetic field due to the first wire will be mu naught by 4 pi current by A, 1 plus 1 by root 2. So 1 plus 1 by root 2, I can write it as root 2 plus 1 by root 2. Root 2 plus 1 by root. So now I want to find the net field at that point. So the net field at that point will be double the field due to any one of the wire. They will contribute equally by symmetry. So therefore, this will be 2 into mu naught by 4 pi current by A, and then you have root 2 plus 1 by root 2. Is there any option which is matching? Is there any option which is matching, guys? Come on. Is there any option which is matching? 2 and 4 will cancel. Yes, 2 and 4 will cancel. It will become 2 pi. And root 2 is there. Okay, current is there. Okay. And oh, we have to find the value of x. I think yes, definitely I can see some option is matching. Mu naught I by 2 pi a, and then you have root 2 plus 1 divided by root 2. That 2 is already there, mu naught is there, I is there. So I think root 2 plus 1 by pi root 2. Root 2 plus 1 by pi root 2 into a. Yes, that is option A, I believe. Can you see that, guys? Yep. Just compare it with this. Yep, just compare it with this. So the value of x, because mu naught is taken outside, even current is taken outside, even 2 is taken outside. So our final answer will be root 2 plus 1 is there, and you have pi a root 2, pi a root 2, which is option number A. Is that clear? Which is exactly this value of x which you have to figure out over here. Perfect. Let's go to the next question. Yep. Awesome. No, if you're a NEET student, A for AIMS only. A for Apple is for first standard. You are not in first standard. You are in 12th standard dropper. Yeah, so for you guys, it is NEET. So A for Apple, B for Baswasaurus, C for Captain Shreyas, D for AIMS Delhi, or D for Diksha ma'am. That is how it is. Three long straight wires A, B, C are carrying currents as shown, then the resultant force on B. Oh, the resultant force on B will be which side? Okay, this is nothing but the concept of currents which are parallel or anti-parallel. What is the force between those wires? Remember, there is a formula, mu naught I1, I2 by 2 pi D is the force per unit length. And if the wires are in the same direction, they will attract. So we have to find on B, right? So on B, there will be one attraction like this. The value will be mu naught current 1 into current 2 divided by 2 pi into D. So that is the force per unit length on that wire. That will be attraction because the wires are carrying currents in the same direction. Similarly, there will be attraction between B and C also, but it will be here. And the value will be mu naught I1. I1 is nothing but 2. I2 is nothing but 3 divided by 2 pi D. Now, obviously, you can see 1 into 2 is less, 2 into 3 is 6. That is more. So, obviously, this is higher or this is more. So, this contribution is definitely less. So, where will the net force be? The net force will be in this particular direction because that is higher. Yeah. So, which side will it be? Towards C. Towards C, as I have shown. The net force will be in the right hand side direction. Yep. Option B. Excellent. B Pakka. Correct, Minecraft. Very good, Krishna, Atluru, Sushmita. Yes, Mamta. Yes. Oh, Bablu. Who is this Bablu? Ayo, I like this name, Bablu. Such a cute name. I hope you become very popular for the right reasons. Okay, moving to the next question. Three wires are carrying constant current. Oh my God, look at this diagram. First wire like this, second wire in the middle upwards, third wire like this. If it is not seen clearly, I will show it. First wire like this, second wire like this, third wire like this. Current directions are given. Loop 1 is around all three of them, and loop 1 goes like that. Loop 2 goes like this. Loop 3 goes like this. Loop number 4 is going like this. The arrow marks might look very small on your screen. That's why I'm clearly demarcating all of them. Question is, if you apply the Ampere's loop law for all of them, then what will be the result? Ampere's loop law. Come on. Very nice question. Match the following type. Hi, Mohammed. Yes, your capto is here. What do you think is the correct answer for this? Let's think. Come on, my dear students. Loop 1, if you apply, loop number 1, if you apply, you are going like this. Your fingers are going like this. Yes, the fingers of your right hand are going exactly like this. So that direction, when you hold, you will see the thumb will point in upward direction. So that will be positive current. So as you can see, when you take loop 1, the middle current is upwards, the other two currents are downwards. So the enclosed current in the upward will be positive, all the other two will be negative. So minus I, minus I. So it will be minus I. So the net enclosed current will be minus I. I think you can see minus I over here. So I think the first answer is 1 only directly. Can you see that, my dear students? Can you see that first answer is minus 1? So you have to use right hand thumb rule. Yes, correct. Let's go with the second one. For loop number 2, you're going anti-clockwise. Oh, okay, like this you are going. So that means my fingers are curling of my right hand in this particular direction. So my thumb will be pointed downwards. So downward direction will be positive. So when I take the enclosed current, downward currents will be positive. So this and this are positive, the outer ones. The inner one is negative. So it will just be I. So it should be just plus I. I can see it right over here. Oh, this is already matched. B is going with 2. B is going with 2. Is that okay? No, loop 1 current is not 0. Net current is not 0. You can see middle one is going up. The other two are going down. So they will not cancel perfectly. Only these two will cancel. Okay. Now if you take loop number 3, guys, just take loop number 3. One current is going downwards, other current is going up. So what will happen for loop number 3? I think the net current will be 0. So I think C is with 3. Already it is matched only. C is with, yes, C is with 3. Can you see that? Because for this particular loop, as you can see right over here, yes, the enclosed current is I minus I, which is basically big fat 0. So the right hand side should be 0. Very nice. The last one for loop number 4. For the loop number 4, one current is up, one current is down. So again the same thing, right? Again the same thing. Do not say, sir, the answer for that will be this option. D is with 4. No, even this will be this because the net current is 0. The total enclosed current, one is going up, other is going down. So I minus I, which means it is 0. So the right hand side is 0. Is that okay, everyone? Clear? So I think it should be option C. A with 1, B with 2, C with 3, D also with 3. Yeah, nothing else will match. Nothing else will match. So it is C for Captain Shreyas. How many of you got it? No, it is not B option. Sir, but one loop enclosed all the 3 wires. Yes, Christina. But see the direction also, right, Christina? What is the direction? One current is up, other current is down, other current is down. So two currents will have the same sign. The third current will have exactly opposite sign. So the currents also carry sign as per the right hand rule. Keep this in mind. Understood now? Yeah? Is this clear, Christina and others? So please remember, whenever you are going across a loop like this, if you're traveling like this, curl your fingers of your right hand, curl your fingers of your right hand, then the thumb will point in the positive direction. So any wire coming like this will be positive current, whereas any current going like this inside will be negative then. That is how it works. Is that okay now? Yeah, this is our loop through which the currents are going to pierce. See if this is absolutely clear. Okay, great. It depends on how you travel. Now, please remember, if instead of going like this, if you go like that, then whatever was positive will be negative, whatever is negative will become positive. If you go exactly opposite, obviously the thumb will point down. So whichever direction the thumb points, that becomes the positive direction. So that is the logic behind this particular question. Moving on to the next one. If there is a bar magnet freely suspended, then the work done to rotate through an angle is work done to rotate through an angle. Freely suspended bar magnet. That means what happens? The magnetic moment, this is north pole, this is south pole, will be exactly in the direction of the magnetic field. So the theta value will be 0, obviously. So initial magnetic energy will be mb, negative sign cos of 0. So it will be basically negative mb. So this is the initial condition. It will be stable equilibrium. It is in stable equilibrium when it is freely suspended. Is that clear? So freely suspended, it will be in the stable equilibrium. So now you are rotating it by some angle. So this particular magnet, okay, is now being rotated. So this is the magnetic moment. Okay, so this is, let's say, theta. This is, let's say, the field. The final energy will be minus mb cos of theta. That is the final energy. So now talking about the work done to rotate the magnet, the work done in rotating the magnet, the work done is final energy minus the initial energy. Final energy is minus mb cos theta minus initial energy is minus mb only, minus mb only. So minus minus just becomes plus mb. So I can definitely take mb outside, and what is left is 1 minus cos theta. Yeah, because there was minus mb cos theta over here. So minus cos theta is inside. So mb 1 minus cos theta is D for doctor. Yep, D for doctor, the fourth option, correct. Many of you got it correct answer. Very nice. Proud of all of you. Moving on to the next question. The variation of magnetic susceptibility for absolute temperature for a ferromagnetic. Interesting. They have asked for a ferromagnetic substance. The answer will be different if it was para. The answer is different if it was dia. You should know all the three graphs, and we have discussed this. Come on, let's see who are the smart ones who remember ferro. By the way, if it is a diamagnetic substance, then what happens is the susceptibility is negative. Susceptibility is going to be negative and it will be a constant, and that is true for diamagnetic substance. It is negative and constant, not positive. Here it is positive, which is not correct. It does not change. This option B, as you can notice over here susceptibility is inversely proportional to temperature. That is called as the Curie's law, and that is valid for a paramagnetic substance. For a paramagnetic substance. Okay, so that is also not the answer. What happens when a ferromagnetic material is taken? Susceptibility is very large for a ferromagnetic substance, but when the temperature goes above the Curie temperature, then the ferromagnetic materials turns into a paramagnetic material. That means the susceptibility will go down and it is inversely proportional to temperature. So as you can see, there is a Curie temperature which will be reached over here. This is your Curie temperature. Susceptibility is very high. After that, it becomes inversely proportional to temperature, just like a paramagnetic material. So this must be then the ferromagnetic material, which is option A. Got it? I have explained in detail what the other graphs are. Yeah. Yes, Curie's law, Krishna, correct. Very good, Minecrafter. Yes. Yes. Oh, somebody from Salem. NTT 303. Ayo, what is your name? Yeah, please tell me because I am also from Salem. Yeah. I feel very happy when I see somebody from Salem, Tamil Nadu. Thank you so much. Nice to see my fellow people out here. Vanakkam. A substance is placed in external field if the direction of the induced dipole moment is opposite to the direction of the applied field, then the substance may be. This is direct theoretical. Either you know it or you don't know it. Yeah, what do you think it is the correct answer? Yes, if it is opposing the external field, that means it is trying to make it weak. It does not love the field. It is repelling the field. Go die. Yes, diamagnetic. Diamagnetic. If it supports the external field, either it is para or it is ferro. If it supports very strongly, then it is ferro. If it supports temporarily and weakly, then it is a paramagnetic substance. Yes, answer is B. Very good. Next one. The rate of change of the torque with the deflection in the maximum is maximum for a magnet suspended freely in a uniform magnetic field of induction when the rate of change of torque. Okay. What is the formula for torque? Torque is mb sine theta. Rate of change of torque. That means d tau by d theta is mb derivative with respect to theta of sine theta. Therefore, the rate of change of torque with respect to the angle will be mb derivative of sine theta will be cos theta. Now I want this term which is there, the rate of change of torque with deflection, this guy should be maximum. That will be maximum when cos theta is maximum. And when is cos theta maximum, guys? When is cos theta maximum? The cos theta's maximum value is 1 when theta is nothing but 0 degree. So lot of people make this mistake and they say 90 degree. I would have, oh, thankfully you guys did not say 90 degree. I'm very proud of you. Yes, the answer is 0 degree. Awesome, my dear students. Awesome. Very nice question. Very twisted question. I'm pretty sure in the actual exam, many people will mark D. They will just think torque is mb sine theta. Torque is maximum when theta is 90. No, they have asked rate of change of torque. So cos theta will come when you take the derivative. If you take a magnet as compared to the width and breadth, the time period of the oscillation in a vibration magnetometer is something, I think 2 seconds maybe. The magnet is cut perpendicular to its length into 3 equal parts and 3 parts are then placed on each other with their like poles together. The time period of the combination will be. So I'm not sure what was their magnetic time period originally. I'm not really sure. Let's just assume it as T. Original is T. I don't know what the T was. Okay, it's not printed over here properly. It's okay. You will just try to solve it. Understand what is exactly happening. You are having a bar magnet. You are having a bar magnet which is like this. This is the north pole, this is the south pole, okay, and it vibrates with some time period. So let's say this was the magnetic field in which it was kept. So definitely it will oscillate back and forth because of the torque, and the torque being mb sine theta. For small angles it just becomes mb theta. So the torque is directly proportional to theta. So this thing becomes the constant. Therefore, the time period of oscillation becomes 2 pi under root moment of inertia divided by the constant, which is nothing but mb. So there are vibrations here. So this is the time period. This is the time period of a vibrating magnet, which is also called as a vibration magnetometer. Don't get scared. It's not there in the syllabus. No, nothing like that. It's there. Okay. Next. Now we are cutting it into 3 pieces. But how? Perpendicular to the length. This is the length. perpendicular to the length. So I will get three pieces like this, 1, 2 and 3 over here. Three pieces like this, perpendicular to the length, and they're placed onto each other such that this is the North Pole, North Pole, North Pole, South Pole, South Pole, South Pole, such that their North Poles and South Poles coincide with each other. Okay, so it will basically become like this, maybe. I'll just draw it over here. Okay, so this is the North Pole, this is the South Pole. All right. Now, when you cut into small pieces, tell me what will be the moment of inertia of each small piece. Tell me quickly in the chat box. If original moment of inertia was I, one third of that magnet, one third of that rod will have how much moment of inertia? Obviously, sir, it will be I by 3, I by 3 and I by 3, sir. It will be I by 3, I by 3, I by 3, sir. Correct? Each single piece. That's what you will think. But is that true? Is that true? Are you sure the moment of inertia will become one third? Are you sure that the moment of inertia will become one third about the central axis? Think about it. Why should it become one third? Because when you add them, no, it will not become one third, guys. That is the catch. That is the catch. No, it will not become one third because their masses might become one third, but their lengths also are becoming one third. Remember, the old formula for the moment of inertia would have been ml square by 12. Now, each of them, new moment of inertia will be mass is divided by 3, length is also divided by 3, the whole thing divided by 12. So it will become ml square by 12. 3 and 9 will become 27. Oh my God, this will become I1 by 27. I by 27, sorry, I by 27. I is ml square by 12. This is crazy. The old moment of inertia is just this one. 3 into 9 is 27. So it becomes 1/27th. Lot of people are going to make this mistake. Got it? Very good, Siva. Excelente, Minecrafter. Yes, Krishna. Oh, yes, sir. Now what, sir? I'll tell you. When you place them onto each other, their inertias will add up. So it will become I by 27 plus I by 27 plus I by 27, three times of that, which will make it I by 9. That is the new moment of inertia of that magnets which are placed over each other. Tuck, 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 you are placing it, you will just add their moment of inertias. Okay. What about the magnetic moment? That is also remaining. Do not forget that. 3 bar magnets made from first magnet. So each one of them will have a magnetic moment m by 3, m by 3 and m by 3. Each one will have m by 3, m by 3, m by 3. When I combine them together, m by 3, m by 3, m by 3 will add up and again give me m only. Oh, so the magnetic moment comes back, but the moment of inertia will change. Got it? Such a lovely, lovely question, guys. So now to find that new time period, the new time period will be 2 pi under root moment of inertia, which is now I by 9, of course, divided by mb. M is m only, b is b only. M is m only, b is b only. Oh, what do I get? I get 2 pi under root I by mb, but root of 1 by 9 is 1 by 3. Root of 1 by 9 is 1 by 3. And what is this exactly, my dear students? What is this? 2 pi under root I by mb. That is the old time period. So that means it will be the old time period and that number 3 will come below. So I think the old one was 2 seconds. I think the time was 2 seconds, what which would have been given to us. 2 seconds. So hence the answer will be 2 by 3 seconds. Option B. How many of you loved the question? I'll repeat what and all happened. Big magnet was there. You are breaking it into 3 parts. Just to vibrate, this is the formula. 2 pi under root I by mb. The moment you break it into parts, moment of inertia and magnetic moment will change. Yeah. So what is the new moment of inertia? Mass became one third, length became one third, ml square by 12 rod formula. So 3 into 9 is 27. Inertia became 27 times less. But when you again place them one over each other, it will then add up become I by 9. Magnetic becomes one third moment, but when you again place them, it will again become m. So in this formula, I becomes I by 9, m and b remains as it is. So this part of the equation resembles this time period. So only that root 1 by 9 comes as 1 by 3. So it will be time period by 3, which is 2 by 3. Not lovely, Ninja. What is that? Is that some neuron, some brain freeze? Some whales are dancing? Okay. Yeah. Oh my God. Somebody's still stuck with what is time period. Okay, don't worry. It was not printed. We just took it as 2 seconds, and I think that was what was the question was. So time was maybe 2 seconds only. Okay, moving on. Next question. Two long wires are separated at A and currents are I1, I2 respectively. The distance from the wire B where the net field becomes 0. Very nice question. Come on, we have to think how to solve this. First of all, two long wires separated, I1, I2 respectively, and they are carrying some currents. You have to find a distance from the wire B where the magnetic field becomes 0. So let's assume this is wire 1 carrying current I1, this is current 2, okay, and they are separated by distance of A, like this. Okay, they are separated by this particular distance. Now, if this is A, this is B, you have to find a distance from B where the net field is 0. Okay, now let's understand. Because of this current, take your right hand, take the thumb towards you. The fingers will curl like this. The fingers will curl like this. Take this guy. Again, the fingers will curl like this anti-clockwise. As you can see, somewhere in between, this line is going up, this line is coming down, they might cancel out each other. So somewhere in between, the magnetic fields will cancel. So I can clearly see somewhere, let's say from B it is asked, right? The distance from the wire B. So let's assume that distance to be X. So from this current I1, the magnetic field will be like this. From this current I2, the magnetic field will be like this. They will end up cancelling each other. So this is B2, this is B1. So since the net field is 0, B1 will be equal to B2. They will cancel out each other. So what is B1? By the way, this particular distance, needless to say, it will be A minus X. It will be A minus X. So field at this point due to this current will be mu naught current 1 divided by 2 pi A minus X. Magnetic field due to this wire at this point will be mu naught I2 divided by just X, mu naught, sorry, 2 pi X, my bad. 2 pi, mu naught will cancel. I think we need to just cross multiply over here. So I1 into X will be I2 multiplied by A minus X. That is what I am getting till here. Is that okay? All right. So bring X terms together. So I1 into X minus I2X is there. So it will become plus I2X is equal to I2 multiplied by A. So take X common. If you take X common, I will get I1 plus I2 is equal to I2 multiplied by A. So here X will be equal to I2A divided by I1 plus I2. I1 plus I2. Where is that option, my dear warriors? Yes, where is that option? Magnetic, everything is fine. Yes, from that wire B. So I can see that option B. Yes, option B. Very good. Excellent. Excellent. Capto current carrying in the same direction or opposite direction? Very good question, Siva. That is not mentioned. I think that is missing. Here we have assumed it in the same direction. Maybe the answer will be different if it is in the opposite direction. Here, let's assume same direction. That's a very good question. In the same direction, it should. I'm just assuming if it is opposite, then the answer will be completely different. Then the answer will be different. Is that okay? Very good. Excellent. Moving on to the next question, guys, on your screen. If there is an alpha particle moving with some velocity in a uniform field, the magnetic force will be direct cross product. Come on, everybody should be able to do this. Direct cross product, guys. Alpha particle. That means what is the charge? Charge is positive 2e. And we have to find the force given by Lorentz formula. Charge velocity cross producted with magnetic field. So charge is nothing but 2e. Velocity is u I cap plus u j cap cross product with the magnetic field, which is B times of K cap. Now I can see U and B will be common. I can just take it outside. So 2EUB, I will just take it here. I just have I cap plus J cap cross producting with K cap. Okay, now this becomes simpler to solve. 2EUB, I into K. I into K. Guys, come on, think about it. What will be I into K? I, J, K. So I into K will be negative J. It will be negative J. J into K. J into K will be positive I. Yep, that is what it is. So it will be 2EUB I cap minus J cap. That is the final answer for that force. I cap minus J cap, which is C option. 2EUB I cap minus J cap. If you're wondering how did Sir do this simple cross product, put I, J, K like this in the clockwise fashion. How the clock goes, I, J and then K like this. If you move in this fashion, then it is positive. If you move in the opposite fashion, then it is negative. So check this out. When I did I into K, I got J, but I'm going anti-clockwise, so negative. When I did J into K will be positive I. If you can't do it mentally, draw a rough diagram and do it. Don't be a hero. Yeah, don't be a hero. Oh, no problem. Winter beat. I think all the students should be given free data plan to watch YouTube classes, right? I think that should be the new scheme now, because students these days want to learn online, whether it is through some app or whether it is through some website, or want to give some test series online, or want to watch videos on YouTube, right? So at least for these apps, YouTube and these study apps which are there, I think if I was Ambani, or maybe I was maybe the owner of something, I would have definitely made it either very reasonable or as much as possible free. That would be so amazing, so that no student should ever feel that my data pack is over. Fine, whatever fees you are paying to the institute or for the platform, that is different, because those platforms also have to run, but at least for the network purposes, it should be very, very cheap. It should be like 10 rupees. You are getting, I don't know, some 20, 30 GB, 40 GB, like that it should be, or maybe even 100 GB. Yeah. Moving on to the next one. Two different magnets are tied together and allowed to vibrate in horizontal plane when their poles are joined. Time period of oscillation is, and with unlike poles joined, time period of oscillation is something, the ratio of the mag. Oh my god, guys, I feel some questions the values only are missing. I can't solve it otherwise, but I'll tell you the method of solving it. Some values are missing, so I'm just trying to tell you. Remember, the time period of oscillation was 2 pi under root I by mb. So that is the formula used here. So two different magnets tied together are allowed when their like poles are joined and versus their unlike poles are joined. Okay. Now, since their magnets are, of different values, so the magnetic moment first time will be m1 plus m2. Second time it will be m1 minus m2, because first time their like poles are together. Second time their unlike poles are together. So magnetic moment will be different, but moment of inertia, which is I, that will still be the same. That has got nothing to do with the orientation. Whether the magnets are like this or like this, still the moment of inertia will be the same. So essentially, I feel T1 by T2 will be root of, here you will have M1 plus M2, and here you will have M1 minus M2. Okay, so the ratio of their magnetic moments is as, so when you square them, you will get T1 square by T2 square is M1 minus M2 upon M1 plus M2. If you want, take the reverse of this, so it will become M1 plus M2 by M1 minus M2. Usually put plus on the top, minus below. That will be T2 square by T1 square. Now use a concept called dividendo. When you do that, numerator plus denominator and numerator minus denominator, you will get over here M1 by M2, and over here you will get T2 square plus T1 square, and here you will get T2 square minus T1 square. So these values are not given. Time period of oscillation is, if those values are given to me, I can substitute that, and next step only will be my answer. Did you understand the method to solve it? Values were not given. Okay? Yes. Yes. Is that absolutely clear? Yes. Great. Moving on. Yeah. So the options which come out, if the values were given, is 5:4, but there is no point discussing the options because we do not know that. So if it was 5 and 4, then you are getting it, but it's okay. We are not knowing the values, so ignore that. Anyways, long needle magnetic moment and pole strength is broken into two pieces at the middle. The magnetic moment and the pole strength of each piece will be. Okay, see how the magnet is broken quickly. There is a magnetic needle whose length is basically 2L, and the magnetic moment is M, and the pole strength is M. So this is plus M, this is going to be minus M. It is broken into two pieces at the exact middle. So when you break it into two pieces like this, one piece over here and the second piece over here, what happens is the pole strength will remain the same. This is minus M, this will be plus M, this will be plus M, this will be minus M. So pole strength will be the same. The length will be less. So the magnetic moment will become M by 2. So the magnetic moment of each one will be M by 2. Yes, magnetic moment will be M by 2. Pole strength will still remain the same. Is that okay? Yep, that is option C. What do you think the answer will be if I cut it like this along the length? If I cut it along the length, can you guys guess it? If it was cut along the length like this, then obviously their lengths will be the same, but this will be plus M by 2, plus M by 2, minus M by 2. Pole strength will be less, but magnetic moment again will be M by 2 only. Yeah. So both will be M by 2, then option A will be correct. Yeah. Then option A will be correct. Pole strength will reduce, length will be the same. So magnetic moment will again become half. Option A. No, it is not B. It is option A. Be careful. And if you have forgotten, magnetic moment is the pole strength multiplied by the magnetic length. So here the magnetic length becomes half. Here the pole strength becomes half. So every time in these two cases, one of them is becoming half, the other one is staying constant. But whatever happens, the magnetic moment is becoming half, either due to length becoming half from 2L to L, or the pole strength becoming half. Magnetic moment in every case is becoming half. Is that clear, everyone? What an question. So that is how you solve questions at home. You make some variations in it. Next one on your screen now. The intensity of magnetization with the magnetizing field in a diamagnetic substance. Diamagnetic. Be careful. Diamagnetic. Yes, diamagnetic, guys. So imagine we have diamagnetic substance. So what will happen in that diamagnetic substance? The magnetic moments will be exactly trying to oppose the external field going through it. This is the external field which is going through it. So this is that external field. So that is also the direction of H, which is the magnetizing field, B naught by mu naught. This magnetizing field H. It's in this direction, whereas the magnetic moments are here. So the intensity of magnetization will be opposite in direction. This intensity of magnetization will be opposite in direction. As you increase B, H will increase, even magnetic moments and I will increase, but in the opposite direction. So which one is the correct one? Yep, it will be either one of these two. It can't be positive because if H is positive, if H is positive, then clearly I is supposed to be negative because it is opposing it. It is opposing it. So obviously A option and B option are neglected, eliminated. Out of C and D, remember diamagnetic weakly opposes, not strongly, weak. It is weakly, it is a very weak opposition. So it will not be very much. So this is very strong. This is very strong opposition. This is very weak opposition. So this strong will be eliminated. Weak opposition is correct. So it should be OC, which is B option. Yep. B for biology, OC. Understood, guys? Why this option is eliminated? So much thinking is involved. Theoretical concept is there. That is how NCERT will be used for framing questions. Lot of students think if I read NCERT, I will get 180 marks in physics. Either they are following a wrong teacher or somebody has fooled them very nicely. Many people tell this. It's not like this is not there in NCERT. This is there in NCERT. Intensity of magnetization is opposing the field and it weakly repels. How do you look at it graphically? If some graphs are given, can you identify it? That comes only through proper problem solving. No matter how much I teach you, no matter how many lectures I give of magnetization, it's of no use. That is why I say, don't waste your time, crucial time making notes now. Yes, don't waste your time making notes now. Now is the time to actually sit and solve lot of questions. You will be like, sir, where do I get notes? Either take somebody's notes which are concise or buy those ready-made notes. And let me tell you, there is a very good option where you can get these notes in our NEET crash course, and many of the students have been using these popular flashcards. The link is there in the description. First of all, smash this like button. As you go into the description box and you see the NEET 2025 crash course, click this particular link. It's a pure English batch for physics, chemistry, biology. Do you see the entire NEET crash course with NEET QR cards? NEET QR cards. This is additionally with All India Test Series 180, the new test series. Many students have been buying this. Yes. And some students who had already bought the test series, they are not buying it. But students who want the test series are buying this as well. These are offline papers couriered to you. So this includes those small QR cards. It looks something like this, which I can show you. It's something like this. It's crazy. It's this small. It's this small, guys. Yeah, you can get it delivered to your doorstep. This small. Yeah, there are many pages in this. You can play cards if you don't know physics. If you want to learn physics, then please use them and revise. Save your time. Be smart. Don't try to be a hero making notes at the last moment. This crash course has obviously assignments, handwritten notes, online test series, recordings, live classes, everything is there. And yes, the batch is starting 17th of March. And remember, the offer of Vidya Utsav, which is valid now, is only there for the next 2 days. These prices will change obviously as soon as the Vidya Utsav offer ends. So make the best use of it right now. Okay, moving to the next question. An iron rod of susceptibility is subjected to this magnetizing field. The permeability of the rod. I mean, I don't know why this was even given. Without that also I can do it, because the relative permeability is 1, sorry, relative permeability is 1 plus magnetic susceptibility. So 1 plus 599 is nothing but 600. But that is relative permeability. Relative permeability is permeability upon mu naught. So that is 600. So mu will be mu naught multiplied by 600. What is mu naught? 4 pi 10 to the power negative 7 into 600. Yes, 4 6 are 24. So 24 pi, 2 zeros swallowed. Inside this, it will become minus 5. So 24 pi into 10 to the power minus 5. But if you want to write it as 2.4, then it will be 10 to the power minus 4. Yes, 2.4, 10 to the power minus 4. It is the same thing, guys. You can write it shifting one decimal inside. You don't have to put so many negative powers. Then it will just become negative 4. Correct. Is that clear, my dear students? Very good. Option D. So you might be wondering, sir, what is the use of this? This is waste fellow. This is completely waste fellow. No use. Chumma to confuse you. Next one. Flux in a closed circuit varies as shown. What is the field at this time? What is the field at this particular time? Yes, what is the, sorry, induced current, my bad. What is the induced current at this particular time? Okay, so what we can do, to find the current, I need the EMF. To find EMF, I need to use Faraday's law. Faraday's law says that the induced EMF is nothing but d phi by dt. So I need to take the derivative of 6t square minus 5t plus 1. 6 is a constant, goes outside. T square's derivative will be 2t, minus 5 will come, times derivative will be 1. 1 is a constant, derivative is 0. So this will be 12t minus 5. Okay, so that is the EMF. But we have to find the current. So current is EMF by resistance. So it will be 12t minus 5 by the resistance, which is, where is it? 10 ohms. Okay. So at 0.25 seconds. So that current at this particular time, you substitute that. So 12 by 10 into 0.25 minus 5 by 10. I'm separating both the terms. So what will it be? Come on, guys. 0.25 is nothing but 1 by 4. Yes, 0.25 is nothing but 1 by 4. 4 goes by 12 3 times. So this is basically 0.3. This 5 by 10 is nothing but 0.5. Yep. So this will be nothing but 0.2 but with a negative sign. Yes. So this will be nothing but negative 0.2. But the question is, find the magnitude of the current. So negative 0.2's modulus is obviously 0.2 ampere. Remember, they just are interested in the magnitude. So it is B for Basosaurus. Correct. That is it. Yo. Very good, yaar. Christina, Ninja, Atluru, Krishna. Excellent in Minecraft. Very good. Hashtag 0047. Very nice. Very nice. Next one. There is a loop which is placed in a field. The flux through the area vector is how much? Direct question of flux. What else can it be? Flux is magnetic field dot producted with area vector. The dot product has to be taken. Straightforward question. So 0.02 I cap dot product with 30 I cap plus 16 J cap plus 23 K cap. This is centimeter square. Be careful. So into 10 to the power minus 4. So that I convert it into meter square. But we know when you take dot product, I cap only multiplies with I cap. J and K will be completely waste fellows. So this will be 0.02 multiplied by 30 multiplied by 10 to the power negative 4. Now you can see what I can do. I can just write 3 into 2. That 30 will have the 10 to the power 1. This will have 10 to the power minus 2, and this will be 10 to the power negative 4. So this will be 6. This is 1 minus 2 is minus 1, minus 1 minus 4 will make it minus 5. 6 into 10 to the power minus 5 Weber is that flux. So 6 into 10 to the power minus 5, but I want it in micro. So I can write it 60 into 10 to the power minus 6 Weber, which is nothing but 60 micro Weber. Micro. 10 to the power negative 6 is a micro. Option A. Very good, Krishna Siva. Excellent, warrior Pandus. Very good. Srishti, Susmita, Christina. Awesome. Awesome. Hashtag 0047 Ninja. Atluru. Excellent. Keep answering like this only. Very proud of all of you. Going on. Come on, guys. Let's speed up. Magnetic flux through a coil varies with time as shown in the diagram, which graph best represents the EMF in the coil with the time. This is the flux. What will be the EMF? Think about it. As you can see, the flux is a sine curve. Maybe it is some phi naught sine omega t. Obviously, the EMF will be negative d phi by dt by Faraday's and Lenz's law. So whatever I do, sine's derivative will be cos, positive cos, and that minus sign will remain. So something will be there over here, something will be there inside the bracket, definitely. So it will be a minus cos curve. Minus cos curve. Which of the following is a minus cos curve? Cosine graph, but a negative cos. So remember, cos graph starts from here. This is a cos graph, whereas minus cos graph exactly starts from below like this. So this is negative cos. So negative cos, I believe, is option C. Yes, negative cos is option C. So hence option C is the correct answer. Cos 0 is 1, minus cos 0 is minus 1. So it should start from a negative value. Such a small thing which needs to be observed. So your observation skills, your analysis skills are being tested over here. Okay? Otherwise, it is very straightforward. If you take a rod moving with some speed, the velocity of the rod after time t will be, it's on a conducting frame, I believe, conducting frame, yes. A conducting rod is projected on a frictionless frame. So what will be the rod's speed after some time? Think about it. What will happen? As it moves, obviously the flux changes. Obviously there will be motional EMF. Obviously there will be motional EMF. Because of that, there will be some current. There will be some current which will be there in the loop. Because of that, there will be I squared R loss in the form of heat. Now, where will this heat come from? Obviously, that loss will come from the mechanical energy. The mechanical energy. That means the kinetic energy will reduce. So, the kinetic energy reduces. So, definitely the speed reduces. Definitely the speed reduces. So after some time, the new speed will be less. So option C is the correct answer. Yep, option C is the correct answer. How many of you gave option C? That is correct. No, it will not be the same. Why should it be the same? Because there is going to be definitely some loss. Okay, very good, very good. Awesomeness. Moving on to the next question, guys, on your screen now. A copper rod is drawn out normally through the magnetic field. Okay, copper rod is drawn out normally, magnetic field perpendicular. This is how it is being drawn. Potentials will be positive, negative. One will be more, one will be less. Who will be more, who will be less? Come on, guys. In such questions, I'll tell you how to get the direction of the EMF, the direction of the motional EMF is always given by the quantity V cross B. V cross B. Take the velocity, cross it with the magnetic field. See, that rod is coming towards you. Velocity is towards you. Magnetic field is towards your right side. Do V cross B. Come on. Do velocity cross B. Velocity is towards you. Take the four fingers of your right hand. Cross it with the field. Thumb is going upwards. So obviously, this is the direction of V cross B in this case. So that is also the direction of the EMF. Meaning, if you replace it with a battery, so the battery's positive terminal will be here, negative terminal will be here. So that is how the current will try to go. Oh, that means this is the negative terminal, this is the positive terminal, this is higher, this is lower potential. Very simple. So basically the potential at P will be greater than at Q. Can you see that? This point P is at higher potential than at Q. Absolutely clear, everyone? Awesome, awesome. Moving on, next one on your screen. This is very simple. Meanwhile, I'll just drink some water. I think I have the water over here only. Yes. This type of question, always guys, whenever you have something solid filled inside and the question is on field, whether it is gravitational field, whether it is solid sphere, and you have to find the electric field, or whether it is a solid conducting wire and you have to find the magnetic field, or whether it is a solid part in which magnetic field is changing and you have to find the electric field. Every single time, the graph is like this. Inside, inside it is proportional to R, and outside it is inversely proportional to either R or sometimes even R square. So always it is a curved line. Yes, option A. Always remember this. By default, you don't even have to sit and solve such questions. Solid sphere, gravitational sphere, a charge conducting wire, sorry, a conducting wire and magnetic field is to be found, or a cylindrical space in which electric field is being generated because of the changing magnetic field. So every single case, it is going to be A. Okay, straight and then curved. When the number of turns in a solenoid are doubled without changing the length of the solenoid. Oh, you are not changing the length of the solenoid. Be careful. So what happens to the self-induction? Well, the self-induction is nothing but mu naught n square A into L. That is what it is. You are not changing the length, but you are changing the turns. So this small n technically is number of turns per unit length. So that is how it is. So it will be mu naught n square A, length and length square will cancel, L will remain. So as you can see, length has not changed. This is length, don't get confused with inductance. Mu and A are the same. So length is directly proportional to the square of the, proportional to the square of the number of turns. Therefore, if the number of turns is how much doubled, square of it will then become 4 times. That is what will happen. So I think the answer should be 4 times. Yes, that is correct. So you should know this formula. If you know it, it's very easy. Else you will be stuck. Okay, very good. Excellent. Moving on, moving on. Ready for the next question on your screen. The diagram shows, wow, crazy LR circuit. The switch is just closed. The current through R1, R2, R3 are I1, I2 and I3. R1, R2, R3. Okay. The value of I1, I2, I3 at time 0. This is very conceptual question. If you are my DNA student, RNA student or NEET Express student, you would know this by now, that whenever an inductor is just connected, inductor is just connected, is just connected, is just connected, then the inductor behaves like an open switch. But in the steady state, in the steady state, after a long time, you will see that the inductor behaves just like a simple conducting wire, as if it is not even there. It will not give any resistance, nothing. It will just behave like a wire. But here, the question is, it is just connected. That means what I need to do, I'll just show you. You need to forget that there is an inductor. You should feel that as if it is not even there, and you should just ignore that part. It is an open switch. Oh my God. There is nothing over here. That means clearly it is obvious now. I2 current will be 0. I3 current will also be 0. No current can flow because it's open. It is going to behave like an open switch. Just what we are predicting over here. Is that clear? Oh, so I2, I3 is 0. But what about I1? Oh, now only this part of the circuit will remain. Only this part. Now the switch is just closed. So the current will only go over here. Nothing can go on the other side. So that's how the current will go. So that current I1 will be that EMF, and there is only one resistance, so R1. That's it. So that is the only thing remaining. So option B, I guess, B for biology. Yes, that is the correct answer. Only I1 will be there. I2 and I3 both will be a big fat 0. What a brilliant question, guys. Many students do not know how to solve these questions. Many students get scared of these questions, but the trick is so easy. If you know this trick in the exam, within few seconds, you will be able to solve. You just need to know which inductors or capacitors you need to get rid of. By the way, for capacitors, what is the theory, guys? Quickly put it up in the chat box. If instead of the inductors, let's say the same question was there with capacitors, what is the theory then? It is exactly opposite. So when it is just connected, the capacitor behaves like a wire, and after a long time, the capacitor behaves like a open circuit. It's exactly opposite. Okay. Awesome. Awesome. Ninja, I hope you understood the trick. Now, what is the trick? Yeah, great. So the trick was to whether convert the inductor into a open switch or open circuit or a wire, or same thing with the capacitor, but it is exactly opposite. Okay, keep that in mind. Yes. So capacitor does not love DC. So when current tries to flow, it will block it. So after a long time, current through the capacitor will be 0. Okay. What about this? The network shown is a part of a complete circuit. If at a certain instant current is 4 ampere and it is increasing, then what is the voltage difference? Crazy question, guys. Let's see what will happen. What is the voltage difference? So first of all, in this particular thing, there will be a voltage drop across that inductor, and that is given by magnitude of L di by dt. The inductance is 5 milli, so 5 into 10 to the power negative 3, di by dt 10 to the power 3. Is that right? 10 to the power 3. So minus 3 plus 3 cancels, it will just become 5 volts. So the voltage drop across the inductor is magnitude wise 5 volts, but direction wise, well, since it is increasing, understand what happens. If inside an inductor, the current increases, if the current increases, the inductor does not like it, it will behave as a battery which will oppose that change in the current, and that opposing EMF is exactly this. So that will be 5 volts. So this same diagram, I can redraw it as if this is point A. You have a resistor of 1 ohm, then you have a battery obviously of 12 volts, and another battery over here of 5 volts. And then this is point B, and the current in the circuit, how much is it? 4 ampere. 4 ampere. It is given over here. That's it. That is the equivalence diagram. Understood, guys, how we converted this diagram to this diagram? So if the current was decreasing, then it will not like that decrease. Then these terminals will be opposite. It will help with the current. So it's like when you are at home and you say, I want to go to party, I want to chill out with my friends. Then you will get one scolding. Why are you going out with your friends? Stay at home. Then it is a holiday and you say, I want to stay at home. Then you will get one scolding. Why do you want to stay at home? You don't have friends, huh? What, such a loser you are? You don't have friends? Go out, go and play. Always opposing. Same thing inductor will do. If current increases, the battery will oppose. If current decreases, the battery will support it. So it's like that. It is an opposing thing. Yeah, absolutely. Now use KVL. So that's it. So voltage at point A plus, and going in the direction of the current, so there will be a drop of I into R. Current is 4 and resistance is 1. Then high to low, so again there is a drop of 12 volts. High to low, again there is a drop of 5 volts. Finally, I reached my destination, so that is VB. So therefore, I will get VA minus VB will be 4 plus 12 plus 5. 4 plus 12, 16. 16 plus 5, 21. So 21 volts will be the answer for VA minus VB. But the question is something else. The question is now what is VB minus VA? So it will be negative 21 volts. So option C will be the correct one. What a brilliant question, guys. It's a very good question. I am telling you, this question will decide whether you are 650 above or not. Yeah, because many students will get 21, but they will get confused, plus 21 or minus 21. So the sign convention should be correct. You cannot make any mistake in the signs or calculations. You should know how to apply this Kirchhoff's law. When you apply this Kirchhoff's law, but it is not a complete loop, you can still apply Kirchhoff's law. You are starting from a point and you reach some point. So this is the initial point, this is the final point. So voltage at the initial point plus some voltage difference here, voltage differences here. Finally, you will get the voltage at the final point. So this is how you apply Kirchhoff's law from a point to another point. Is that clear? Amazing, right? All right. Great. Okay, moving on. Next question. The length of a thin wire required to manufacture a solenoid is of inductance and length. Yo, what is this? Length of a thin wire. If the cross-sectional diameter considered less than its length, something is missing. I think inductance is L, length is L. Okay, if the cross-sectional diameter is considered less than its length. Okay, what do you think, guys? Okay, guys. Yeah, Ninja, please watch my old classes. It will definitely help you. Yeah, I think that is why you are facing that difficulty. Watch my theory classes, 100%, all the tricks, everything I have mentioned, everything properly. So, if the length of the wire required to manufacture that solenoid is asked, inductance is given, length of the solenoid is given, okay, and if the cross-sectional diameter is considered to be less than the uh, length, okay, cross-sectional diameter, I think something else is missing over here. Some misprint is also there because something like LL is not given. Length of that wire, guys. See, because if I use this formula, capital L is mu naught n square A into L. This will give me mu naught number of turns square by L square into A into L. But that cross-sectional diameter is very less as compared to the length is given. From that, A is not given. A lot of things are missing. So I think some questionable thing is there. But I mean, just look at it. N square, this is L and this is A over here. So if you had to find out L, it will be mu naught N square A divided by the inductance. So that is what it would be. So the length of that thin wire. We have to find the length of that thin wire, not the length of the solenoid. So if at all you take each turn to go like this, the length of the wire, if I assume it as x, that will be circumference multiplied by number of turns. Circumference will be 2 pi r multiplied by basically n, but I don't like that circumference like this in terms of r. Radius is not given. So what I will do, I'll convert it into area. I know one thing for sure, that the area is pi r square. Therefore, A by pi is r square. Therefore, r is root of a by pi. So how about using that r over here? I'll write it as area of cross section divided by pi. Okay, so this is 2 pi into n is basically the length of that wire. 2 pi r, which is root of a by pi, into n. Now I can see over here, I can get the value of n from this equation and substitute it over here. So what is the value of n? What is that particular value of n that I'm getting from here, guys? I can see n square will be, okay, this is just L. So n square will be capital L, which is inductance, multiplied by small l, which is the length of the solenoid. This is that small l, don't get confused. This capital L is inductance. The whole thing divided by mu naught divided by A. So therefore our n will be root of capital L small l divided by mu naught multiplied by A. It's in the denominator. So use this over here. So let's see what do we exactly get. Therefore, x will be 2 pi root of area of cross section by pi. All right. Here, instead of n, substitute this. Instead of n, substitute inductance, length of the solenoid, by mu naught into A. Best part is that our area of cross section is getting cancelled. Area of cross section beautifully got cancelled. So what I will get is x is equal to, okay, pi and root pi will make it root pi on the top, and over here capital L small l by mu naught. So it will be 2 root pi LL divided by mu naught. That is what it is. 2 is basically outside. If you want, you can bring it inside also, and then it will become, if you want, you can bring it inside also. It will become 4 pi capital L small l divided by mu naught. That is your x. X is the length of that wire. This is the length of that particular wire which will be needed. Okay, so 4 pi LL by mu naught, it is B option. Yes, it is correct. So I think the only thing missing over here in this particular question which was misprinted, inductance is capital L and the length is small l. Those were the things which were missing in the problem. Isn't it amazing, guys? Okay. Yes, yes, yes. 0047. We have taken it as L and capital, and then I solved it. Yeah. Ninja, please listen to what Minecrafter is saying. Whatever is there in my mind exactly has told the same thing. Ninja, the series la cap to detail I explained. Panirupu paru ungalaku atu useful irkum. Correct. Hi Capto, tomorrow CBSE math exam. After that, kindly do JE section also. Definitely, definitely, Nikhil. But I won't be there in the crash course completely. I'm there in few lectures. Other classes, I think, taken by, if I'm not wrong, Vipul sir or somebody. Yeah, yeah. So teachers who are teaching in your pro batches only are taking. We are not keeping any other teacher because this is obviously JE crash. So we only keep our pro teachers in our JE crash course. Yeah. So don't worry. Awesome. Okay, let's go. Let's go to the next one. Beautiful question. And here it is on your screen. If there is a generator producing voltage given by blah blah blah, the frequency, oh my god, come on, this is very laddu question. Frequency. First of all, 120 will be your omega. Omega is nothing but 2 pi f. So therefore, f will be 120 by 2 is 60. So 60 by pi. Now, pi is basically 3.14. So come on guys, 60 divided by 3.14, 60 by 3, that will be 20. So 3.14 means it will be less than 20, slightly less than 20. So it can't be 754, it can't be 60, it has to be 19, there is no other option. So it will be 19 hertz. Perfect. Next, what is the question? What is the RMS? So the RMS is the maximum by root 2. So the maximum is 240 by root 2. So 240 by root 2. Come on, guys. You can just write as 240. 1 by root 2 is 0.7, approximately 0.7. So how much will it be? Yeah, come on, guys. How much is it coming out to be? 240 into 0.7. 7 by 10. 0, 0 cancels. 24 into 7, approximately. Just check. Is it coming close to 170 volts? 170 volts, guys. Close enough to? Yes. Correct. Yeah. Awesome. 19 and 170. Very good, guys. Awesome. No, it is not B. It is C option. Yeah, it is C option. Be careful. Yeah. Close enough to 170. Yes, that's enough. Approximate answers are needed. Moving on. Pure inductor 25 millihenry is connected to a source. Find the reactance for this frequency. Reactance of inductor. Formula is omega L. Omega is 2 pi f into, and this is L. So 2 pi f, what is the frequency? It is 50. What is the inductance? It is 25, but it is in milli. Okay. So 2 into 50, 100. 2 into 50, 100. Okay. Into 25. Okay. Into 10 to the power negative 3. So I will get this as 25 into pi, which is roughly 3.14 multiplied by 10 to the power minus 1. Is that right? 2 into 50 is 100, 25 is there, pi is there. So this 100, this 100 and 10 to the power minus 3 will become 10 to the power minus 1. 25 into 3 is 75. So 3.14 means it will be slightly more than 75, but there is one decimal. So basically, I think this should be close enough to 7.85 if I'm not wrong. Yes, 7.85. Yep, perfect. How did I do it? Did I sit and calculate it? No, Shreyas sir did not sit and calculate. What did Shreyas sir do? See guys, I did one simple thing. 25 is there. 25 into 3 is 75. So 25 into 3.14 will be 75 plus. It will be more than 75. It will be more than 75. So because there was 10 to the power minus 1, so 2.5 into 3.14 will be 7.5 and slightly more than that. So what is slightly more than 7.5? 7.85. Got it? Yeah. 0.707, that standard value you should know, my dear warriors. Yeah, this is a standard value which you should know. 1 by root 2. Root 2 is 1.414. But this value which is there, it comes 0.707. But approximately you can call it zero point 0.7. Yeah, approximately you can take it as 0.7. That is something which you should again know. All these are standard values. Moving to the next one, coming up on your screen, resistance, inductance, connected in series, 20, 200, the phase between voltage and current. Wow. See guys, such an amazing question. Such an amazing question for all of you. Okay, you have to draw the triangle. You have to draw the triangle. Clear, Capto, okay. Everyone is clear. Everybody is understanding. Guys, have you smashed the like button or not? Or do I have to still remind you? All those new people out here, join, subscribe, like. Standard thing. Attendance has to be marked. Your sincerity has to be seen. If it is not seen, we will not be there on the channel. Understand that, because we have lot of batches to take care. We have lot of things to take care of. We come only because you show love. You don't show that respect, you don't show that attendance, you don't show that love, you don't put those comments, we will feel, oh, that channel is showing more importance, oh, that channel is showing more love, support. We will think, oh, those students need us more. You have to call us, you have to demand for it, you have to demand for more classes, put comments, smash that like button, show that strength in subscriptions, and then we will be here. Understand that? Okay, moving on. Describe. Okay, sorry, what is this? Resistance is given, inductance is given, finding the phase angle. Okay, so I think we have to find the inductive reactance first. Without that, we cannot proceed ahead at all. So XL is omega L. Omega is 1, no, it's not 1. It is 2 pi f. So 2 pi f into L. What is the frequency? Frequency is 200. What is the inductance? It is 1 by pi. Okay. Best part, pi, by. So 2 into 200 is 400 ohm. Okay, great. So my inductive reactance XL is 400 ohms. Just my resistance, is 300 ohms, and resistance is always in phase with the current, and whatever their resultant is, which is the impedance, that is always in the direction of the voltage in the phasor diagram, and this becomes your phase angle. So I think we can take tan phi over here. Tan of phi is opposite side by adjacent side. Opposite is XL, adjacent is R. So it is 400 by 300, which is 4 by 3. So therefore, theta, or basically that phi over here, is nothing but tan inverse of 4 by 3. Tan inverse of 4 by 3. Every time, whenever you see AC problem, don't sit and remember just formulas. At the end of the day, it is usage of vectors. If you know vectors and how to use it in the phasor diagram, you will get it. Yeah, this is something which I have taught in AC. Please check out my AC lectures. Those of you are wondering where are my AC classes or any class for that matter, it is right over here on the channel, guys. Yeah, when you go over here, I can search for anything. Let's say alternating current. Just even search alternating, more than enough. Alternating current, complete NCRT line by line, NCRT Super 6. What more you need? NCRT perspective, NCRT lines plus PYQs, NEET perspective also. Everything is there on the channel. You just have to use it. If you take this AC voltage connected to a capacitor, the reading of the ammeter will be. So you have to find the current in the circuit. You have to find the current. So that means you have to find the capacitive reactance. Without that, you cannot proceed. Okay, shall we proceed? How do we find the capacitive reactance? XC is 1 by omega C. Omega, from here, clearly it is 100. Capacitance, 1 micro, so 10 to the power negative 6. So this will become 10 to the power minus 4. So it will just become 10 to the power 4 ohms. So that is XC. Now, coming to the current part. Current is voltage divided by resistance, in this case capacitive. So voltage is 200 root 2. Reactance is 10 to the power 4. 2 zeros goes. So it will become 2 by 10 to the power 2 root 2. But this is not any ordinary current. It is the maximum current. But what reading you will get is always the RMS. It will be always I naught by root 2. That means it will be 2 root 2 by 10 raised to 2 by root 2. Root 2 cancels. So it will be 2 by 10 raised to 2. Yes, 2 by 10 raised to 2. This will be obviously in amperes, but the answer asked is in milliamperes. So it will be 2 by 10 raised to 2 into 10 to the power 3 milliamperes. Because minus 3 is milli, plus 3 is 10 raised to 3. They will eventually cancel. That's how I do the conversion. 2 zeros, 3 zeros, 1 zero will remain on the top. So 20 milliampere. So 20 milliampere is Bussosaurus. Perfect. That is the correct answer. Everyone? Yep. Awesome, 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 awesome. Very cool. Very good, very good, very good. Excellent, guys. Moving on to the next question. If you take a voltage of peak value 300 and angular frequency 400 applied to the LCR circuit, resistance, inductance, capacitance, the peak current, same logic, guys, please do it as homework. I'm not doing this again. It's the same thing. Here you have to find XL, which is omega L. Omega, if you ask me, it is already given. So it is basically 400 into inductance, which is 20 milli, which is 10 to the power minus 3. Similarly, you find XC, which is 1 by omega c, which is 1 by 400 into capacitance is 625. 625, but that is micro. Perfect. You also know the resistance. So that's it. To find the resistance, first find the impedance. Impedance is R squares plus XL minus XC whole square. Just do that. You will get impedance. Then you will get the current. Current is basically uh, maximum current will be maximum voltage by impedance. So maximum voltage is 300. So 300 by whatever Z you get, you put it over here, you put it over here, that's it. You will get the value of the current. It's very straightforward. So solve it and see if you get the answer as 60 amperes. Solve it and see if you get the answer as 60 amperes. Yes. So that means the impedance that you get should be, I think, 5. So Z should come out to be 5 ohms. Just check it out. After substituting XL, XC, R, everything, it should come out as 5 ohms. Yep. Cool. Shall we go ahead to the next one? Coming up on your screen. LCR diagram is shown. Capacitance, resistance, frequency, which drive the circuit at resonance. Resonant frequency is asked. Okay. So, resonant frequency is nothing but 1 by root of LC, omega. But remember, omega is nothing but 2 pi f. So, substitute the value of L and C both. Inductance is 5. Capacitance is 80 micro. 80 micro. Micro is 10 to the power negative 6. So, therefore, 2 pi multiplied by f will be 1 by, check this out, 80 into 5, guys, is 4400. Okay, so you will have root of 400 multiplied by minus 6. So root of 400 is 20. 10 to the power minus 6 root is minus 3. Okay, so that is 2 pi f, of course. What you can do, you can just write f is equal to 1 by 20 into 2 is 40. So 40 pi minus 3 goes on the top, becomes plus 3. Okay. So 0, 0 cancels. You will get 10 to the power 2 by 4 pi. So that is 100 by 4, which is basically 25 by pi. 25 by pi. But whatever answer you get, it will be in hertz. It will be in hertz. That's it. So that is the answer. So option B, yep, that is the correct answer. You just have to solve it. It's substitution based, direct formula based, and that's how you get the answer. Cool. Moving on. If there is a AC circuit containing a resistance and a inductance, the impedance is, oh my god, this is a direct question. Impedance when there is no capacitance is R square plus XL square. There is no XC only. And XL is omega L. Oh my god. And what is omega? Omega is nothing but 2 pi f. So it will be 4 pi square f square, and then there is L square. That's it. That direct it is. So it is directly option C. There was nothing great about it. Such a laddu direct question. Imagine it comes. You should be so happy. You should be jumping with joy. Isn't it? Next one. LCR circuit is there. AC current, frequency F, the graph of impedance versus frequency. Impedance versus frequency. Be careful, my dear students. When you have current versus frequency, that graph goes up and comes down. And remember, current is voltage by impedance. So when current goes up, impedance comes down. When current goes down, impedance goes up. So it should be exactly a flip of it. But will it touch zero? No. Impedance will become minimum but not zero when resonance will occur. Yes. So answer will be A. Answer will be A definitely, because what happens is at resonance, this will be I max. This will be your frequency of resonance. This particular impedance will then become R. All of this at resonance. All of this at resonance. But it is definitely not zero. Here it is becoming zero. So C option is wrong. Here this Z will become R. Otherwise, impedance is more, so current is less. Okay, so this is exactly happening at resonance. So option number A. Very nice. Next question. The potentials across capacitance, inductance, resistance, everything is given, and the power factor of the circuit is, wow, power factor cos phi. That means I need the triangle, the vectors, the phasors. If I draw the phasors properly, I will definitely get the answers. So how do I draw the phasors? Well, resistor's voltage is 80 volts. Resistor's voltage is always horizontal. Okay. Voltage on the capacitor is always below. So this is how it is. Voltage of the capacitor 40 volts. Voltage of the inductor is 100 volts. Okay. So this is basically voltage of the inductor, which is 100 volts. These two I can take out easily. 100 up, 40 down will make it basically 100 minus 40, which is basically 60 volts. And resistance will always remain like that, 80 volts. So taking their vector sum, that will be the total voltage. The total voltage will be 80 and 60's sum, vector sum. So which will be 80 square plus 60 square root, which will be basically 100 volts. Oh, that's it. My power factor I can easily get now, because this is also the phasor of the current. This will be phi. So I just have to find cos phi, the power factor, which is nothing but cos of phi. Cos phi is adjacent by hypotenuse. Adjacent is 80, hypotenuse is 100. So obviously it is 0.8. 0.8. Can you see that? Yep. 0.8 is option A. Very good. Awesome. Many of you gave the correct answer. Krishna, Minecrafter, Ninja, refreshing. Why are you getting lag? There is no lag. Next one. Current and voltage are given. Voltage leads the current by how much? Very good question. Both are sine. I is having minus pi by 6. Voltage is having plus pi by 3. Oh, current is having minus pi by 6. Current is having minus pi by 6. And voltage is having, so current is having minus pi by 6. Voltage is having plus pi by 3. So what will be the total angle between them? Minus pi by 6 plus pi by 3. So the total angle, pi by 6 means 30, pi by 3 means 60. So 30 and 60, that will be basically pi by 2. That's the difference. So pi by 2 is option A. Yes, very good. Option A is the correct answer. How many of you got it? Very good, Siva. Awesome. That was very quick. Very nice. Very nice. Great. Great. So I can see that we have solved almost 45 questions now. Yes, I can see that we have solved 45 questions because we are on slide 92. First two slides were intro. So we have solved 45 questions. Last 5 questions, homework. Last 5 questions, homework. Where you will get the homework? In the PDF. Where will be the PDF? In the description box. So there are 5 more questions. Very laddu questions are there. Okay. So I am pretty sure you will be able to solve them. 5 questions only are there as homework. Cool? You will be able to do it? Yes? Great. Where will the PDF? Description box. When will it come? Tomorrow. Okay. It will come tomorrow. All right. That link will be there. Great. Awesome. So all the best, guys. Do not forget to like and subscribe. That's very important. It's mandatory. Okay. I'll see you tomorrow for the next unit, which is modern physics. Okay. Bye bye. Have a great time. Good night. Stay safe. Stay healthy. Eat well. Yeah. Enjoy what you are doing. Don't do it out of boredom. Be passionate about whatever you are learning. Do not forget what you are doing this for. Even if you feel sleepy, even if you feel tired, even if you feel exhausted, even if you feel like doing nothing, push yourself, compel yourself, force yourself to do it, and try to derive pleasure in the smallest of the smallest things. Okay? There is no magic pill which has to be swallowed. The magic lies purely in your hard work, your dedication. Okay? And the guidance that we are giving, obviously, that is the secret. So make sure you are on the channel till the end. Lot of lectures coming in. I want everybody to complete the 7 days 1000 questions challenge. Every session 50 questions. 3 sessions 150 questions. 7 days more than 1000 questions. Apart from that also you should practice. Cool? Bye bye. Take care. Have a great time. All the very best. Hasta la vista.